This little video is about divisibility rules. Divisibility rules are important because you can use them so many different ways. You can use them to reduce fractions. You can use them to find your greatest common factor. They're just some things to really keep in mind when you're working a lot of math problems. Divisibility rules kind of follow in some different categories. The first category divisibility rules fall into are the quick looks. So the quick looks. These are rules that you can follow with just quickly looking at them. The numbers that are the quick looks are the number 2. 2 is a quick look because you're looking at the last digit. And if the last digit is 0, 2, 4, 6, or 8, then it is divisible by 2. Your second quick look is a 5. 5, again, you're looking at the last digit. Is the last digit a 0 or a 5? And then your final quick look is your divisibility by 10. Again, last digit. Is it a 0? And as you can see, these quick looks are all kind of divisible, because anything divisible by 5, if it ends in a 0, is divisible by 2. Anything divisible by 10 is also divisible by 2 because it ends in a 0. Let's take a look at a couple examples on the next page. So if we're looking at our quick look rules, we're looking at our last digit. So 744, that one is divisible by 2. It is not divisible by 5, and it's not divisible by 10. You're looking at that last digit. 228, last digit is an 8. So that one is divisible by 2. It is not divisible by 5, and it's not divisible by 10. Again, in 2006, 640, looking at this number, looking at our last number as a 2, or a 0, it is divisible by 2. Looking at this number, looking at this number here, at the 560, that one, last digit is a 0 as well, so it is divisible by 2. Both of these are divisible by 5 because they end in a 0. And they're also divisible by 10. So those fit all of those. Let's take a look at some other rules for divisibility rules. The next category that I would consider in divisibility rules are numbers that you need to add to find them. Those would be the number 3 and the number 9. Both of these you need to use a similar process. You need to add up the digits for both of them. And I will add up the digits until there's only one digit. So until only one digit on both. And then for a 3, after you get to that single digit, is it divisible by 3? So if you follow the rule of adding it up to one digit, then the number needs to be either a 3, a 6, a 9, and those are the only 3 numbers that that digit would have to add up to. So you have to add up the digits. Is it a 3, a 6, or a 9? Because those are the only 3 single-digit numbers that are divisible by 3. To add up the digits to one digit, you then need to ask yourself, is it divisible by 9? And the only single digit that's divisible by 9 is 9. So if you add up all the digits and they're 9, then it's divisible by 9. Let's look at some numbers with that. So looking at these numbers and seeing if they're divisible by 3, we're going to add up the digits. Remember, digits are the single pieces that make it up. So in the number 744, you're going to add 7 plus 4 plus 4. 4 and 4 is 8. So 7 plus 8 is 15. Still not to a single digit yet. So we have to add 1 plus 5, and that's 6. 6 we know, if we look back at what we looked at for our 3's rule, this one is divisible by 3 because it is 6. So this one is yes to 3, but no to 6, or to, not to 6, to 9. So it's no to 9, because 6 is divisible by 3, but 9 is not. Let's look at 288. 288, we're adding the digits 2 plus 2 plus 8. 2 plus 2 is 4 plus 8 is 12. Still not done, so we need to add 1 plus 2 is 3. So again, this one is yes for 3, but no for 9, because 3 is divisible by 3, but not 9. Again, adding our digits, 2 plus 6 plus 4, and we won't need to add the plus 0 because it's going to not do anything. 6 plus 4 I know is 10, so 2 plus 10. 2 plus 10 is 12. Not done. Add 2 plus 1 is 3. So again, yes to 3 and no to 9. Alright, we'll add these ones. 5 plus 7 plus 6. And of course, we're not going to add plus 0 because that doesn't make any sense, because it's not going to add up to anything. 7 plus 6 is 13. 5 plus 13 is 18. We're not done. We need to add the digits in 18. 1 plus 8 is 9. So this is a yes to 3 and a yes to 9. So when you check 3, you can really check 9 at the same time. The last couple of numbers that we're going to look at for divisibility rules are the number 6 and the numbers 4. 6 is a nice one because it is one that you just have to quick check and you have to look back. To be divisible by 6, it has to be divisible by both 2 and 3. If it's not, it doesn't work. We'll look at some numbers for that in a second. For 4, you're looking at the last 2 digits to see if they are divisible by 4. The other numbers you'll just have to check, and I usually will check, either with my calculator or I'll check with my multiplication chart. So like your 7s and your 8s, those you'll just have to check. Also, you'll need to check any prime numbers when you're doing some more advanced simplification. Let's take a look at some numbers with the 4 and the 6. So if we remember our quick checks, to be divisible by 6, it has to be both divisible by 2 and 3. 2 is the easier one to check, and as you can tell if you look at those last digits, they're all divisible by 2, because they're all a 2, 4, 6, 8, or a 0. So these are all divisible by 2, so we have to follow our 3 rules. So for our 3 rules, remember we're adding up the digits. And we determined that almost all of these are divisible by 3, so we're adding up our digits. 4 plus 4 is 8. 8 plus 7 is 15. Adding these digits is 6. So this is divisible by 3, it's divisible by 2. So this one is yes to 2, yes to 3. So that's a yes to 6. Divisible by 4, you're looking at the last 2. So 744, 44, 4 goes into 44 11 times, so this is also a yes to 4. Looking at the last two digits of this one, our number is 28. 4 goes into 28 7 times, so this is a yes to 4. So it's pretty easy to look at the 4. I usually will use my multiplication chart to help me because most numbers divisible by 4 will be on my multiplication chart. You will find numbers like 60 are not found on your multiplication chart. 44 is also one that's not fall on your multiplication chart. So in those cases, you're going to have to do a long division problem. So you're going to put 60 in here, and you're going to put your 4 on the outside. How many times does 4 go into 6? Well, it goes in there once. So we put our 4 under, and then we're left with 2. We drop our 0. We have 20. 4 goes into 25 times. We're left with nothing. So when we have 0 down here and no remainders, it goes evenly. That's what divisibility is, something going evenly without remainders. So this one is a yes to 4. You can also use some shortcut division strategies too, like we learned a little bit last year for those of you who are in my last year's math class. If we use the shorthand of this one, we have 4 and 60. We're dividing it. 4 goes into 6 one time still, and we're left with the remainder of 2. So we have that goes in there 5 times. So remember how we did that shorthand where we went, it's kind of like this, but we don't subtract here, but we subtract and have leftovers. That's another way to try it as well. It saves you on some paper. I will go over this shorthand method in another video as well. So in short, your divisibility rules mainly cover your 2s, your 3s, your 4s, your 5s, your 6, your 9, and your 10. Remember that 2, 5, and 10 you're all looking at the last digit. Those are ones that are last digits. Our 3 and our 9 are ones where we have to add the digits. And 6 is our dependent number, as it depends on what happens with 2 and 3. 4 is one where you may have to long divide. For all other numbers, all other primes, and 8, you'll have to probably long divide those. Thanks for watching.